All right, the last thing that we're going to talk about in this section is a pretty difficult concept to understand, and it's called the sandwich theorem. It's difficult to understand because it's difficult to think of the sandwich part, but it's actually easy to understand when you see how it works. For example, sometimes in calculus, and not a lot, but often enough, there are things that we cannot find directly. Okay, so sometimes we just can't find a limit directly. However, we can find a limit indirectly by using what's called the sandwich theorem. So if I can find three related functions where one is smaller than the next, which is smaller than the next, in this case f, h, and g, g, f, and h. So if I can find a set of functions so that g is smaller than f, which is smaller than h, okay, where x doesn't equal a specific value, okay, then what I'm looking for is a place where I can get a common limit between g and h, and since g and h are on the edges, if they go to a specific spot, then the middle guy has to also go to that specific spot, okay? So it's really kind of a difficult concept to think about it, but here's the best way to look at it. We're going to Subway. We're going to eat a Subway sandwich. And when you bite into a Subway sandwich, you bite through the bread first, on the top and on the bottom. And inside that Subway sandwich are all the fixins. That's the function we're interested in. The bread at Subway is good, but what makes a Subway sandwich really good is the inside. And the same thing with calculus. We're really interested in that inside part, the really cool part. So G and H become the bread. We don't need this guy. And the F is the sandwich part, the in the middle part. So here's how this would look kind of in real life. If we look at the limit as x approaches 0 of x squared times sine of 1 over x, you'll notice right off the bat that if I put a 0 in here for x, if I put a 0 in, hey, guess what? Then I'm going to get an undefined answer because you cannot have a 0 in the denominator. You just can't. So what we have to do is go, okay, I can't look at this directly, but what if I were to squeeze this entire function in between two others that were a little bit bigger? Now, think about what you know about the sign. The sign will never ever be larger than 1 or less than -1. Okay? So for this particular problem, what we can do is we can look at the x squared part. He's going to be what we can look at. So let's look at negative x squared for the g of x part. And let's look at positive x squared for the h part. Now, if you think about this, the largest that sign can be is 1 or -1. So times x squared, the most that would happen is an equality. Okay, we would have an equality with x squared. So in between these guys, we've got x squared times the sine of 1 over x. So this becomes my f of x part. Well, what do I do? This right here. We're going to look at the limit as x approaches 0. That part doesn't change. But now instead of looking at this purple equation here, we're going to look at negative x squared. And then over here, the limit as x approaches 0. And we're going to look at positive x squared. And so when we do this, what happens is we can substitute 0 in. So 0 squared is 0, and 0 squared is 0. So since both of these guys go to the exact same number, 0, then we can say that the limit of this, the limit as x approaches 0 of x squared times sine 1 over x is 0. And I'll give you a chance to, you could graph this on your own. And when you graph both of these functions, negative x squared and positive x squared, and x squared sine 1 over x, you'll see that the trig graph bounces back and forth between the two x squareds, therefore giving us that sandwich.